Hey everyone, welcome back to the channel. In today's video, we're demonstrating how to solve both single and two-step problems using dimensional analysis, a powerful tool that makes unit conversions and problem solving a breeze. Grab your calculator and let's get started. Problem number 1. The MD orders 500 milligrams of a medication PO every day. On hand, the available strength are 0.25 gram tablets. How many tablets will the RN administer? So I've set up the problem starting with the MD's order, 500 milligrams over the placeholder 1, times our conversion factor, 1 gram over 1,000 milligrams, times 1 tab over 0.25 grams. So we're going to work the problem diagonally. Our milligrams cross-cancel, our grams cross-cancel. We don't need those units, and we are left with tabs in the numerator position, and that's where we want to be. So we'll multiply across. 500 times 1 is 500, divided by 1,000, divided by 0.25, gives us 2 tablets for our answer. A key point in working these problems with this technique is that we're working diagonally. Cross-canceling the unwanted units, we multiply across and then divide to get our answer. So in this problem, we're looking for capsules. I've set up the problem with the MD order, 0.4 grams over the placeholder 1, times our conversion factor, 1,000 milligrams over 1 gram, times 1 capsule over 200 milligrams. We work diagonally, cross-canceling the grams and cross-canceling our milligrams. Next, we multiply across. 0.4 times 1,000 times 1 is 1,000, divided by 200 gives us 2. So the RN will administer 2 capsules. Problem number 3. The MD orders 24 milligrams PO of a medication. On hand, the solution strength available is 12.5 milligrams per 1.5 mLs. How many mLs will the RN administer? So this is a single-step calculation because our units are equal. We're solving in milligrams. So I've set up this problem 24 milligrams over 1 times 1.5 mLs over 12.5 milligrams. Our milligrams cancel, and we are left with mLs in the numerator position, and that's where we need to be. Across 24 times 1.5 equals 36, divided by 12.5 gives us 2.88. Can round to the nearest tenth, 2.9 mLs. Problem number 4. This is a single-step calculation, and we're solving for mLs. The doctor orders 120 milligrams. So I'll start off setting up the equation with 120 over 1 times what's available, 1 ml per 80 milligrams. The milligrams cross-cancel. We multiply and divide. 120 divided by 80 gives us 1.5 mLs for our answer.
Problem number 5. The MD orders 1,400 units of Epogen subcutaneous injection. Available are 2,000 unit ampules. What dose in mLs will the RN administer? I've set up this problem starting off with the MD order, 1,400 units over 1 times 1 ml over 2,000 units. Our units cross-cancel. Now we're ready to solve. 1,400 times 1 is 1,400, divided by 2,000 gives us 0.7 mLs for our sub-Q injection. Problem number 6. The MD orders 0.5 grams PO every 12 hours of a medication. On hand is 250 milligrams per 5 mLs. How many mLs should the RN administer? So I've set up this problem starting off with the MD order, multiplying that by our conversion factor, and multiplying what we have available. Our grams cross-cancel. Remember, we're working diagonally, and our milligrams cross-cancel. So we're left with mLs, and that's where we want to be. 0.5 times 1,000 times 5 gives us 2,500 divided by 250. Our answer is 10 mLs. Remember, we're always working diagonally and cross-canceling the units that we no longer need. Another key factor with dimensional analysis is memorizing the metric table. When you first start off learning dimensional analysis, it's a good idea to have the metric table pulled up as a reference so it's easy for you to refer to it. All right, problem number 7. The MD orders 2,000 mics of a medication. On hand, the medication bottle reads 4 milligrams per ml. I've set up this problem with the MD order times our conversion factor times what we have available. We cross-cancel our units, so micrograms and milligrams cross-cancel, and we're left with mLs. We multiply across and then divide. 2,000 divided by 1,000 divided by 4 gives us 0.5 mLs for our answer. If you find this content is helpful, please consider giving a like, share, and a subscribe. Problem number 8. The MD orders cephalexin 1 gram PO daily. On hand, the bottle reads 250 milligrams per 1 capsule. How many capsules will the RN give? So our desired unit, or units, are capsules, and I've written out the conversion factor. 1 gram is equal to 1,000 milligrams. I've set up the problem with the MD order over the placeholder 1 times the conversion factor, 1,000 milligrams over 1 gram, times what we have available, 1 capsule per 250 milligrams. Grams cross-cancel as we work diagonally, milligrams cross-cancel. We're left with capsules. We multiply across and divide. 1,000 divided by 250 gives us 4 capsules for our answer. Problem number 9. The MD orders 80 milligrams of a medication. The available strength on hand is 100 milligrams per 2 mLs. How many mLs should the nurse give? I've set up the problem with the MD order first, 80 milligrams over 1 times 2 mLs over 100 milligrams. Working diagonally, our milligrams cross-cancel. Next, we multiply across. 80 times 2 gives us 160 divided by 100. 1.6 mLs is our answer. Problem number 10. The doctor orders 650 milligrams of Tylenol PO. On hand are 325 milligram tablets. How many tablets should the nurse administer? I've set up the problem with the MD order, 650 milligrams times 1 tablet over 325 milligrams. Milligrams cross-cancel, we multiply and then divide. Our answer is 2 tablets. Problem number 11. The MD orders 500 milligrams of a medication. Available are 0.5 gram tablets. How many tablets does the nurse administer? So right away we know we're going to need a conversion because of the 2 different units presented in the problem. I've set up the problem with the MD order, 500 milligrams over 1 times our conversion factor times 1 tablet over 0.5 grams. Our milligrams cross-cancel, our grams cross-cancel. Next, we multiply across and then divide. 500 times 1 is 500, divided by 1,000, divided by 0.5 gives us 1 tablet for our answer. Problem number 12. The MD orders PO Elixir 0.25 milligrams of a medication. Available is 50 mics per ml. How many mLs will the RN administer? So we see the difference in units presented in our problem, and right away we know we're going to have to use a conversion factor. I've placed what the doctor ordered, 0.25 over 1 times our conversion factor times 1 ml over 50 mics. Units cross-cancel and we multiply across. 0.25 times 1,000 gives us 250 divided by 50 gives us 5 mLs for our answer. Thanks for watching. I hope this video helped you feel more confident tackling 1- and 2-step conversion problems. Understanding how to solve these types of problems is essential for safe and accurate medication dosing. Keep practicing and we'll see you in the next one.